All right, welcome to day 2 of Advent of Code 2023. If you're new here, I'm just going back through all the days and doing them in C++ because I completed them in Python, and now I want to challenge myself. And day 2 made me want to go back to Python the most I think I ever have, because this problem is not difficult. However, the input processing, when you don't have the dot split command, is perhaps one of the most annoying things ever. Now, thankfully, this was another cool opportunity to use the sliding window algorithm, or a modified version of it. So I'll go through that today. But just to orient ourselves, so basically we're playing this game with the elf, and our puzzle input is a set of lines, and each line represents a game. And so there's some information that we need to pay attention to. The first thing is this game ID, which is just the number of the game which we're playing. The second thing is that each semicolon separates, I guess, kind of a turn or like it's essentially a turn where the elf is pulling some cubes out of a bag, and this is the result of that pull. And then the second semicolon, or all semicolons thereafter, are the result of future pulls after replacement or with replacement. And so the question, or at least in part 1, the question is, what games would have been possible if the bag only contained 12 red cubes, 13 green cubes, and 14 blue cubes? So essentially the idea here is we need to identify any game for which the maximum pull for red is less than or equal to 12, the maximum pull for green is less than or equal to 13, and the maximum pull for blue is less than or equal to 14. And then we want to sum the IDs of those games. And so in order to do that, it obviously seems, relatively straightforward, but because we're using C++, let me just go ahead and make this day real quick. We'll cd into day 2 and pull up our boilerplate code. Wonderful. Okay, so in Python, we would do something like, input.readLines, and then iterate over these lines and simply use the dot split method, right? Now in C++, I'm somewhat new to using this language, or I'm getting back into it, and so I don't recall that there's anything like that, and so we kind of have to make up our own way to do that. Now, the way that I chose to do it was using sort of a sliding window. So the first thing we'll do is just define our limits. So we can have 12 red, 13 green, and 14 blue, I believe. Oops, 14. Okay, and now we're going to iterate, as we normally do, over all of the input lines. And we'll just call that iterator I. And then we'll initialize some counts. So for each line, we'll keep track of the maximum pull for each color. And then essentially what we'll do is we'll say, at the end of this, we'll check if red is less than or equal to red, and green is less than or equal to green, and blue is less than or equal to blue. Then we can add 1 to the answer because it's possible. But the real challenge here is getting these numbers, or extracting them, I guess. So the first thing we'll do is keep track, I guess, of the game ID, or we'll declare a variable for that, so that, or initialize, I should say, we'll initialize a variable such that when we do come across the game ID, we can just store it. And so again, we'll use the sliding window approach here. So I'll initialize a window start, And then while that window start is within the boundary of the current line, we will initialize a window end. And well, it shouldn't be 0, it should be the window start plus 1. And then while that window end is less than or equal to, so notice this operator is important, and it's a key distinction that we're not doing the less than, because we need to make sure that we handle cases where there's information at the end of the string. Because if we just did less than, we would end up actually missing this last character when we use our window. So we need the less than or equal to, and again, input I dot size. And then, okay, so this is where it gets slightly annoying. But essentially, we're gonna extract our window, which is just equal to the substring of the input, from the window start to the window end, or not to. This is again the second parameter of this method is the length of the window, and that's given by the difference between the start and the end and the start, I should say. Perfect. Okay, so now let's find our game ID. So if window.find, so we're going to search within our current window, and we're going to see if we can find the word game. That means that we are kind of hovering around our game ID, right? And so essentially this expression will evaluate to a Boolean. And I looked this up. I wasn't sure how to do the kind of like search within a string in C++, but this end position thing, if my computer will load. Sorry, I have apparently very slow internet. I think might be storming out. I guess it's not going to. Whatever. So this end position thing I think might mean like null position or something. Maybe it will tell me. No, it won't. Okay, well, essentially, like, this is how you check whether a given substring, so like, let's say I have a string S1 and S2, and I want to know if S2 is a substring of S1. The way that I do that is I say S1 dot find S2, and then if it is equal to std string end position, this means that if this expression evaluates to true, this means that it is not a substring. Okay, so given that, we can continue and we can say we're going to actually, so now our kind of big window that's iterating across the entire line we know it contains the word game with a space, right? And if we go ahead and look at our test, or I guess I didn't paste the test input in here. Let me grab that. So if we go ahead and look at our test input, we can see that we basically just need the character right after game, right? And that would work for the test input. However, the real input is quite long. It's 100 games. And so we could brute force this. We could say, okay, well, on the last line of the real input, let's just make it 3 characters long. And then for everything else, we'll do 2. But I'd rather develop a generalizable approach, and I think it's more interesting to do that and more challenging. So what we can do is we can say, all right, well, let's start here. Let's start at that first character after the space. And we're going to go until we encounter another space. We're going to go until we encounter a colon. And as soon as we encounter that colon, we know we've captured our game ID, right? And so the way that we do that is we actually initialize another window within this window. And so we're going to call that, well, first we need an iterator, right? So we're going to call it game iter. And then we will have a game window, which is going to be a string, and I'll just call it game window, and it will start off as our current window, okay? And then while that game window does not include a colon. So again, the way that we check is with this syntax here. We want to increase that game, or we want to add the next character to that game window, I should say, right? And we will start by, so the way that we'll do that is we'll split the input. So we'll split this line starting from wherever our window ended, and we'll go up to the game iter. Okay, and then we'll increment our game iter. Perfect. All right. Now this while loop will break as soon as this colon becomes a substring of the game window. Okay, so when that happens, we know we found our game ID, and we can extract our game ID. We'll cast it to an integer, but we can extract it by grabbing the input starting at the end of our big window and going to our game iter, because our game iter is essentially how many digits are in our game ID is what you can think of the game iter as. Wonderful. And then what we're going to do, so this means that we have this essentially means we're done searching from our current window start. Okay, so we've essentially extracted all the information we possibly can from our current window start, which means not only do we want to break out of this current window end, we also want to move. So this, what I'm adding right now, this line 60 is not strictly necessary. The approach would still work without it, but it just makes things a little more efficient, because now we can skip everything that we've just looked at within this kind of inner loop, right? So I've just added this as somewhat of an optimization. And if it's not obvious why that helps or it's confusing, certainly you don't need to have it there. But the next thing we're going to do is we're going to handle the colors. Okay, so let's start with blue. And then once we figure out blue, we've essentially figured everything else out, and so we'll just copy and paste. So we'll do the same thing. If we encounter blue, so it's not null position. Again, I'm saying null position because that's what I'm guessing, because my internet won't load. So if that's wrong, please just let me know. I'll look it up afterwards too. So anyways, we want to essentially follow the same protocol by initializing a blue window, which is a string. Well, first, I guess a blue iter. Int blue iter equals 1. But there's one really, really important distinction. So game, when we were looking for the game ID, we were searching after the word game. But now, when we're looking for the amount of cubes pulled, we need to search before. So we actually need to do somewhat of a, like our window needs to be moving or expanding backwards, which is fine. We know how to do that, or we can engineer a way to do that. But it makes things slightly more complicated. So our blue window is going to start now at the window end. Okay, so let's say we've gotten here, right? So the window end is going to point, I guess, to here. All right, and we want it's pointing to this E, or it's not. It isn't that E, but it's the index of that E rather. And what we want to do is we want to go all the way back. So because we know what's here, we know there's a blue here, and we also know there's a space here. So we can skip looking through all of those, because really what we're interested in is in the 3 and everything before up to this space. Oops, sorry. And once again, in theory, for the first test case and the second one too, I suppose, it would work to just grab this 3. But you can see we may have non-single digit cube counts. And so again, we want to make a generalizable solution here. So what we're going to do is we're going to, the place that our blue window will start is going to be this 3. We'll start by looking at this 3. And the way we'll get to that 3 is just by subtracting 6 from our window end, because blue is 4 characters long, the space is 1 character long, and then we want to be on this 3. So we subtract 6, and we make our window 1 character long. So right now, we're just looking at the 3. And then, while this blue window, so what we're looking for, again, is a space. The way that we're going to know we've reached the end of our cube count is when we encounter a space. So while the space is not in the blue window, what we can do, std string pose, we can essentially increment, or adjust, I should say, our blue window to include, so notice here, when we were doing the game window, we did game window plus equals, and that's the same thing as saying game window equals game window plus this, okay? So in this case, the plus is a string concatenator operator, or a string concatenation operator. So it's going to put the current game window first and then tack on this next character. But because we're doing reverse search here, because we want to move backwards, we actually want to say, we want to append the next character in front of our current window. So what we'll do is we'll grab that next character by taking the window end -6 minus blue iter, and again, it will just be 1, or of length 1, because we just want the 1 character, and we're going to add the blue window to that. All right, so this is essentially a way to front append or left append a character onto a string. And then we will increase blue iter, or increment blue iter. And it says there's an error here. I don't know. Oh, I must be just missing it. Oh, I think I'm missing an else, which we'll get to. But anyways, so the next thing is that when this while loop breaks, that means we've found that space, and that means we can extract our blue. So I called this variable cur blue, or current blue, because we're going to compare it to our blue for the entire line, or excuse me, our blue for the entire line, because we want to extract the max, right? So we will say, we'll cast it to an integer, and the way that we can grab our current blue is by starting at the window end -5 minus blue iter, because our blue iter tells us how many characters we had to go back, and it will be of length blue iter. And then this is essentially, it accounts for the space and then the entire word blue. That's where the 5 is coming from. So you'll see when we do green and red, we'll have to modify the value by which we're subtracting. And so blue, and blue again refers to the blue of the entire line. We want to find the max pull, so that's going to be std max of blue and current blue. And then we can just break out of our inner loop and move on to the next window start. And again, we'll just jump right ahead up, and so in this case it would jump us to this comma, and we would not have to look at everything that we've just looked at. So we've done this for blue, which means we can do it for red and green. So I'm literally just going to copy and paste this, and I will grab blue. I just want to make sure that my case thing, or my case sensitivity, is on so that I don't mess up. So I'll just do some selecting here with VS Code's built-in feature, and then I will change this to green as well. Notice, however, that as I mentioned, we do need to change the kind of difference value, because green is a longer word than blue. So green is 5 characters long, so we'll just add 1 because blue is 4 characters. So this will be 7, this will be 7, and this will be 6. And then here, I guess this should be blue, because then I can just auto-select everything. And I will change this to red, change this to cur red, and then red is 1 character shorter than blue, so all the 6s, all of these decrement values should increase. by 1. Or I guess decrease by 1. If you're considering the absolute value. Let's see, that was a 5, so this should be a 4. Okay. All right. And then, so yes, we're breaking out, and in the else case, we just want to increment our window end and move and continue and move on. Wonderful. Okay, I'm gonna stop looking at the test input. I'll zoom out a little bit. Oops, that's a bit too much. Maybe I'll zoom in actually so you can see a little better. And then the next thing is just making sure that our syntax is all correct. So I believe we may have an extra curly brace. Is that the issue? No, that is not the issue. Okay, let me figure out what the issue is, because we've essentially written everything, right? So just to recap, we've found the game ID, and then we've counted the blue, green, and red, and we've identified the max pull for each, for a given line. And then for that line, we're going to identify if it's possible by simply running a comparison here. And of course, I forgot the semicolon. Typical Python programmer mistake. And so this should give us our answer. So I'm going to go ahead and compile and then run this code. So I'll do crun p1.cpp, and then we'll run it on the test input first. And okay, that's not correct. Oh, so what I did is I added 1 rather than adding the game ID. There is a reason we had to extract the game ID. So I'll recompile, run it on the test input, and the answer was 8. And then I'll just run it on the real input, or my real input, I should say, as a sanity check. I got 2,169. Here's 2,169. Wonderful. Okay, part 2, very straightforward. Well, let's read it first. So now we want to know what is the fewest number of cubes of each color that could have been in the bag to make the game possible. So we look at, essentially we're looking again for the max pull here, right? Because the fewest number of cubes of each color that could have been in the bag is exactly the max pull for each color for each game, right? And then our answer comes in the form of the power of a set of cubes, and the power of a set of cubes is simply the minimum number of each color multiplied together, right? And so we can literally just copy everything from part 1 over into part 2, and all we need to change is rather than checking this condition, what we'll add to our answer is red times blue times green. And if we compile part 2 and run it on the test input, we get 2,286, which is correct, and then we'll run it on the real input as well, and we get 60,940, and that's correct.